Well, hello Internet, and welcome to part 7 of my UML2 video tutorial. Today I'm going to show you component diagrams and composite structures and go over all of the pieces involved in using them. As well, I'm going to answer some questions that I've been receiving lately. And this is going to be a setup for what is to come, which is using component diagrams and composite structures in pretty elaborate examples. So let's get into it. Okay, so here I am in UMLlet, and this guy is actually meaning this file is going to be included in the link underneath of this video because some of you guys have told me you're having some trouble creating these guys, so they'll be pre-made and ready for you. Components, which this is a component, are used to create reusable pieces of code. Components are combined to create whole programs, and they perform operations, interact with classes, and implement interfaces. However, components tend to perform more complicated tasks than you normally would with a regular class. And like I said, here is a component. And if you have a component inside of a component, you can actually replace this word here, component, with the word subclass. But if you don't want to, you don't have to. Now, components must communicate through interfaces, so they must be loosely coupled and easily swappable. That's the whole concept of a component. And here I'm going to show you 3 different ways to show components and their interfaces and how they connect with each other. Now, the interfaces, and in this situation we actually have 2 interfaces, language in and language out, are going to describe the service that is going to be offered by that component or services. Required interfaces, which this is a required interface, is going to be one that is needed for a component to function. Now this is going to be a language translator, so if it doesn't have any language input, it is completely worthless. And required interfaces are going to have this little half circle or C shape on them. Provided interfaces, however, are not going to need to be used to make the component work. However, more than likely in all situations, it is going to be something that you're going to want to use. Like, for example, this guy's going to take a string from one language in on one side and shoot out a different language on the right side. And provided interfaces are going to be designated with a full circle. Now, like I said, there are 3 main ways to create these, and this is the most common way. Here is another way that you can do pretty much exactly the same thing. And the reason why you would actually designate everything like this versus like this is very compact, where this is more verbose, is to be more verbose. So, for example, if you'd like to say which specific method is going to be used with this component for the most part, well, you would designate that method right here. And if you want to create components like this, you would use what are called dependency arrows if it's a required interface, or a realization arrow if it is a provided interface. Again, required means it must be here or the component's worthless, while a provided interface is going to not be required. And the third way that you can actually designate these guys is right like this. And this is the most compact way. And in this situation, you would just list it as a component and put this little shape up here. That's important. And then you would list provided interfaces and required interfaces, and maybe what is called an artifact or artifacts. And what these would be files, databases, anything like that. Text files, Excel data sheets, anything. So anything that's an actual file type or a way of gathering information would be considered an artifact. So those are 3 different ways to create components. Here is another way that we can show components attaching to each other. Previously, we didn't have components on the other side of these interfaces. And to show how they connect, we use assembly connectors. And as you can see, this is a circle, and this is the half circle. And we would point with an arrow here to show in which direction these components or the data from this component is flowing into this component and then flowing over into this final component. So it's all pretty simple stuff. Remember, for the most part, these are going to be combinations of classes that do something pretty big. And this is just a nice, easy, global way to look at your system and how it's created and how it works together. Now, often components, like I said before, are going to contain many different classes. And like before, there's going to be 3 different ways you can show classes inside of your components. Now, this is going to represent a component, this box right here on your screen. And you can see the 2 interfaces. There's one there, and there's the other interface over over here. And then inside of here, inside of this component, you're going to document or show what classes are going to exist inside of your component and how they are going to interact. And these classes are known as realizations. Sorry, there's so much jargon involved in this, but I figured I'd throw all the jargon into one video. Now, just like before, there is another way to document these guys, and this way actually isn't used very much because it's not very compact and it doesn't provide much more information. But if you would like to document the objects inside of this component outside of the component itself, this is how you would do it. And then you have a pretty common way of setting up components where we're going to list provided interfaces, required interfaces. There's the artifact again. And here are the realizations, which are the classes that are inside or make up your component. And then the final part of using components is using what are called ports. And you can see a port here, and I actually have an arrow drawn inside of it, but they're not always drawn as arrows inside of here. Sometimes they're just simple squares. And you're going to create ports that have related interfaces attached, and you can even give these ports different names outside of just listing out the interface that shoots out here. So let's say I wanted to actually shoot out in multiple different languages. So one language goes in, and one language would come out on the other right side of the screen. Or multiple different languages would come out on a screen. To document that would be quite easy. Let's say that I wanted to mark this as German out and this one as Spanish out, and then actually give this a name for languages out. Well, that's exactly the way that I would do it. I would actually label this port and give this port some information in regards to what sort of output would come out of it, which would be that it shoots out different types of languages. And then I could name each individual interface German out and Spanish out to document that two separate languages would show up in regards to output from this one port. And pretty much the only other thing you need to know about component diagrams is how to use what are called delegation connectors. And this is extremely simple. All you're going to do is just show the flow of the data through your component. So, language in, this right here is known as a delegation connector. It's going to connect to this object, which then maybe would break this string into individual words and then shoot that information out in German as well as Spanish. So these are known as delegation connectors. So there you are. That's pretty much every single thing you could ever want to know about component diagrams. Now, just to review something that we talked about before that has come up in a couple questions sent to me. These are relationship arrows, and I'm going to briefly go over and provide an example of how they work. Now, this relationship arrow that you see up here would be used in situations where you have inheritance, or if you're writing Java code, you're using words like implements or extends. These arrows are used when you have an is-a relationship between two created classes, or a situation where you would inherit, a situation where you would have a class named animal and you have a subclass named dog. That is when you would see these arrows. Then you would have a dependency relationship arrow. This arrow would be used whenever you would want to show that a class depends on something, but that something isn't a member of the class. For example, a class that uses a other object, or a situation in which an object is passed into another object simply as an attribute of a method that's used inside of there and then discarded. Yes, that class or that object uses another object, but it is no way part of the object itself. That is known as a dependence relationship, and you would use this arrow right here. Then you have association relationships. This is a situation in which a class contains a reference to another class or class object. If we go back to our previous example, this would be the situation where a dog would have a specific breed. It has a breed. This is an association relationship. A reference to another object is contained inside of our object, and in that situation, we would use that arrow. Then you have an aggregation, and this is one of the things people have gotten confused about, but I'll clear it up. Aggregations are situations where a class is a container for other classes, but if the container itself is destroyed, the contained object is not. Situation where we would have that is the sports team. Now, even though the sports team may be destroyed, that does not mean the player itself or himself or herself would be destroyed. And that would be a situation where you would have an aggregation, and that's when you would use this relationship arrow. And then finally, we have compositions and this relationship arrow. And a composition occurs when a class is a container for other classes. Like here we have the window for your program. And if the container is destroyed, the contained object is also destroyed. Now, if we have a component, like we have in this situation, that is inside of a window that makes up the whole of your program, if the window is destroyed, definitely the component inside the window would also be destroyed. And that is a composition relationship. So hopefully those examples help clear things up, because I've gotten some questions about it. And now let's get into the simplistic composite structures. Now, a composite structure is going to model how objects work together. Sometimes whenever you find yourself in a situation where a class diagram is not particularly good at showing how different items in a class are going to work together, what we're talking about here is a product as a class, and these pieces here being parts of the class. And here we are going to show how these different parts of our class are going to work together. And that is whenever you would use a composite structure. With a composite structure, you're going to draw items included through composition inside of this big class. Like here we have product, description, picture, user guides, and the company name. And each one of these is going to be a little bit different in how they work. But either way, like I just talked about composition, this is composition whenever you have a container with other objects inside of it. So we're just going to pull that back up there for a second. And how you're going to document these guys is you're first going to have the role name. So this is going to be a product description. And then you're going to have the type for the specific object that is saved inside of your project class. So product pic and picture, which is what it is, attached file and a user guide, company name and string, and this guy's a little bit different, so we're going to talk about that last. Now, what you're going to do here whenever you're creating these different parts of your classes is you're actually going to document the number of instances of these specific objects, and you're going to write that in the upper right hand corner for that object. So in this situation, whenever we have a product object, that product we expect to only have one description. And the number of instances of this object being the description inside of the product class is also going to be known as multiplicity. So 1 represents that there's one instance, and this represents multiplicity. Then over here we can also document that the number of instances is not necessarily known. So we could say, well, with this specific product, we may have 1, 3, 1, 2, 3 pictures of said product. And that is exactly how you would do that. And you're also going to be able to show relationships between parts of these class objects by using what are called connectors. And whenever you're using connectors, you're going to put numbers on both ends of the connector, like I have right here, to designate how many instances match up with other instances. So each description is going to have one picture, or you could actually come in here and put 1.3. That would actually make more sense, because this description, in essence, could have more than one picture because of what we designated up here. And another thing you can do whenever you're using multiplicity, and I'm going to use this picture here as an example, is you could actually put these guys in brackets like this if you prefer to use them that way, instead of putting them in the upper right hand corner of the box like I did just right there. So that's another way of designating multiplicity, or the number of instances of said object inside of the class. Now these guys right here, meaning the description and picture, as well as the company name down here, are referred to as parts inside of composite structures. However, there is something else you can contain inside of a class, and those are known as properties. I know that's a little bit confusing, but just memorize it, you'll remember it. And an example of a property would be an attached file. And these are attached through what is called association, and they may be used by other classes. So in this situation, we have a user guide. It's only ever going to make sense to have one user guide, and it's an outside file on top of that. And in that situation, again, just like we talked about artifacts before and how they are outside files, very often in situations where we have outside files or references to outside data, in those situations, we are going to call those properties, and they are going to be inside of a box that is going to be dashed. And then the final part of this guy is what are called singular instances. Now, if this is a product catalog for a said company, chances are very, very good that there is only ever going to be one company attached to every single product everywhere, no matter what, as long as they are a class of type product. And in that situation, we are going to have what is called a singular instance. And this is just a situation in which you have a specific name that is going to be tied into a constant value, like we have here with company, company name, what have you. In that situation, this is going to be a singular instance. It isn't going to change. It's going to be something that's shared by every product that you are going to use product-wide. And then just like before, we're also going to have ports with composite structures, and ports are going to connect your class to other outside classes just like before. And also just like before, these classes are going to have interfaces, and also more than likely there's going to be specific names for each said port to designate what all of the different interfaces are going to do. So in this situation, we have our product class. Customers are going to be able to view these interfaces, and these are a little bit better named for interfaces, viewable and updatable. And chances are we're going to have multiple different interfaces for the administrator and probably more than likely for the customer. So customer name here is actually going to be tied to this port, and admin's going to be tied to all of the interfaces that come out of that port. And then the final thing you have, which are what are called collaborations. Now, what collaborations are going to do for you is show how objects are going to work together to accomplish said tasks. Now, whenever you're creating multiple different objects, they might not always do the same thing. Their roles may change. So a collaboration is used to show changing specific tasks that objects will have through the use of your system. And participants inside of a collaboration are also going to be listed as role, meaning products, followed by type, and they're going to be linked together with a connector. And then you're going to put in some information in regards to what task is being done or achieved through this collaboration between the product and display object, which is to show the products to whoever you want to show them to. And the alternative way to show collaborations is this guy, and this is the final part of this. Now you know everything about composite structures as well as component diagrams. Here, just like before, we're going to list show products, which is what the goal is or the tasks to achieve whenever you put these two objects together. And then to provide a little bit more information, you're going to provide the exact methods that are going to be called, meaning get product information from the product class and put product on screen. So there is a rundown of component diagrams, composite structures, and some more information on relationship arrows and what they mean and how they work. Hopefully that answers a lot of questions I've been getting lately. If any other questions have come up, please leave them in the comment section below. Otherwise, till next time.